Hey y'all. So today's objective is, we're starting in statistics, and today's objective is populations and samples. Populations and samples. So basically today there's a lot of vocabulary and nothing with a calculator. It's a lot of thinking about and making predictions. So here's some vocabulary, important vocabulary. A population is an entire group being studied. An entire group being studied. So let's pretend we want to study this middle school, Wake Forest Roseland Middle School. That would be the population. Everybody, every student in 6th, 7th, and 8th grade. We could not possibly ask every single student in this school, so we would have to take a sample. A sample is part of the population, so a small part of the population. And there are two types of samples. There's biased and unbiased. And we're going to talk about these in the next slide. But there's two types of samples, a biased and an unbiased. We want to get a good study. We, or anyone that's doing a study, wants an unbiased sample. So it's representative of the population. So that word representative, write that down. Representative. That means it represents the population. For example, if the population was our school, would I just survey the football team? No, that is not a representative sample of our school. That would be a biased sample. If I wanted to survey our school, would I just survey kids getting out of carpool? No, because that is not a representative sample of our school. And then the last word is inference. I had to call Miss George for help. An inference is a prediction or an educated guess. So we're going to use the information, we're going to use some data from our samples to make an inference. And that is the goal, is making an inference. Alright, so a little bit more of the vocabulary. Biased and unbiased. So biased samples are usually out of convenience or voluntary. So convenience means like the first 10 people that walk in somewhere, or the first 100 people that fill out this. Those are convenience, and they might not be a good representative sample. The next one, voluntary. If you ask people to do a survey and they don't have to, then that's not going to get good results, because only certain types of people are going to do it. Other people are going to throw it in the trash can and say, forget this. So if it's voluntary or convenience, then those are biased. And examples would be, like I said, voluntary surveys and maybe the first 100 people to walk into the grocery store. Those would be biased samples. Unbiased samples is what we want. Those have to be random, completely random. Everyone has to have the same chance of getting picked, and those create unbiased samples. And you can make, for example, drawing names out of a hat. If everybody's name is in a hat, that would be random, that would be unbiased. Every 10th person, so let's say we're at Walmart, and you're going to survey every 10th person that walks in, then that is not a convenience. That is going to get a random sample. And then, or let's say you split it up and you want to survey half boys and half girls. You do 25 girls and 25 boys, and you would make it even and random. And inferences, you have to take inferences from unbiased data. Inferences come from unbiased data. Alright, so example 1, here's what I expect. I expect you to copy down the problem, but you do not have to write down A, B, C, and D, but write down the problem. That's what I'm going to be looking for tomorrow. Write down the problem. A market researcher wants to know how 18 to 25-year-old women spend their money. 18 to 25-year-old women, that's our population. Which group is the best representative sample? So we want to look at 18 to 25-year-old women. That's our population. So which one would be the best representative sample? A, 18 to 25-year-old women in college. Okay. 18 to 25-year-old women in college. Are all 18 to 25-year-old women in college? No. Some 18 to 25-year-old women are already working. Some are going to be at home. So you have to think, would that be a good representative of 18 to 25-year-old women? B, 18 to 25-year-old women at the mall. Okay, what kind of women go to the mall? 18 to 25-year-old women. Could they be working? Could they be stay at home? Could they be in school? So you got to think, what kind of 18 to 25-year-old women would be at the mall? C, 18 to 25-year-old men and women. Oh, we do not need men, so we know it's not going to be C. Women of all ages at the mall. All ages, we only want this specific, so we do not want D. So we've narrowed it down to A and B. Now we have to pick. Which one would give the best representative sample? Only asking women in college or asking women at the mall? And the correct answer is asking women at the mall, because you have the chance of asking random people and not just people who are in school. This could get anybody 18 to 25, whether they're in school or they have a job or they stay at home. So the mall would be the best choice. All right, example 2. Write down the question. You do not have to write the answers down, but write down the question. Which method is most likely to produce a representative sample? Again, we see that word, representative, which means unbiased. All right, so a survey by mail to send back. If you got something in the mail and it said fill out the survey and send it back, that would be voluntary. Oh no, blue marker. Pick the first 30 people that enter a room. First 30, that would be convenience. Pull 30 names out of a jar, that would be random. Survey members of a football team. So football team, that's too specific. So when you read all of these, the one that gives the best representative sample would be C, pulling 30 names out of a jar, because that is totally random. Everyone has a unique chance. The problem with the football team is not everybody plays football, so that doesn't give everybody a chance to be surveyed. All right, example 3. What is the most valid inference? So now we're taking the information, we're taking the data, and we're going to make an inference, like a prediction or an educated guess or an observation. So which one is the most valid? We have colors, black, yellow, green, pink, blue, and these are the number of people who prefer that color. So 74 people picked black, 105 people picked yellow, and there are, oh, that's not 100. I don't know, 700 total? 700 total. So A, black is the least preferred color. So let's look at our data. Black definitely has the smallest, but can we say for sure that it's the least preferred? Or is there anything else close to 74? Yes, 79. So that's not big enough for us to say it's the least preferred. It's small, but it's not significant enough for us to say least preferred. More students prefer blue than black and green. So blue than black and green. So here's green and here's black. So is it true that more students prefer blue than black and green? No, that's not true. We can see that the numbers do not equal up, so it cannot be B. Blue and green are preferred colors. So let's look at blue and green. They're both in the 200s. Are they both significantly higher than all the other colors? Yes, they are both significantly higher than the other colors. So I think that is a good inference. Let's look at D. Pink is preferred to black. So we have 79 pink and 74 black. So I ask you, is 79 to 74 a significant amount? Can we say for sure that pink really is preferred to black? And the answer is no, because the numbers are not significant. Remember, you have to look for significant amounts. So let's go back to A. Black is the least preferred. I think we've established that it's either going to be black or pink. And so blue and green are the preferred colors. Alright, so example 4 is a you try. So I expect you to copy down this chart and the question, and then you can pick your answer A, B, or C. So which is the most valid inference? Most valid. They might be valid, but you need to pick the most valid. Out of what food is preferred? Hot dogs, tacos, or pizza? So you copy this down, read your inferences. We'll go over this tomorrow, and this is the first lesson in statistics. See you tomorrow.